I can find the rate of change of a function. So we looked at how to find the initial value. Now we're going to look at what's called the rate of change, and it's basically how fast something happens. Um, a better idea would be to say as the x value goes up by 1, how much does the y value change? The y value could go up, it could go down, it could stay the same, just depends on the function. And there's also the idea that the y value of the output is completely dependent upon the x value. So let's go a little bit further and see what we can find. What's the rate of change of this functional relationship? Joe eats 13 donuts every morning. So far, he's already eaten 4,745 donuts. The initial value we learned is what's already happened, or the starting point. The rate of change is how fast that is going to start to change. And you can see that Joe's going to continue to eat 13 donuts every morning. So we're going to say our rate of change is 13 donuts every morning or every day. One thing that we'll come to realize as we go through all of these rate of changes, that the rate of change is going to be usually a certain speed, and speed is related to time. So we'll find the number, the change, how fast it's going, and then we need to always make sure we list, are we talking mornings, are we talking hours, seconds, whatever that is. Make sure you make a note of that. It makes it a lot easier as you go through and do these problems. What's the rate of change for this functional relationship? Carl earns $8.50 per hour. So far, he's already earned $24.50. So he's already earned this, and the $24.50 is going to increase or change every hour, and it's going to go up $8.50. So that is our rate of change. Again, you'll notice that I'm making sure I list what the time element is here. It's per hour. How do we find a rate of change on tables and mapping diagrams? We know the initial value for this table is 4. Well, it's not too difficult. Look at the change of value that you see in your x's. Here it went up by 3, and here it went up by 3. So for every 3 unit changes in x, there's 3 unit changes in y is what it looks like. You would take your y value, or the change in y, and divide it by your x value. So we would be looking at this. So it looks like my rate of change would be 1, but let's go through and check some other points here. Right now we're dealing only with linear functions, and that's something that makes it a little bit easier. 3 goes to 4, so that was a change of 1. 7 went up to 8, so that was a change of 1. 1 divided by 1 is 1. Let's look at this one though. 11 goes up to 56. Let's see, that's a change of 45, and 15 went up to 60, so that's a change of 45. 45 divided by 45 is 1, so we still have the same rate of change. Let's do this table over here, and I'll write down that we had a rate of change of 1. Here we don't know what the time element is. We just have the inputs and outputs, and we don't know what given scenario it is. So we'll just keep it generic. My initial value is 7, but I also see that my x's went up by 5, and here it went up by 5 also. Let's see here. This one, it decreased by 4, and 1 went down to -3, so that decreased by 4. If we have our idea of our change in y divided by our change in x, 5 divided by 5 is +1. -4 divided by -4 is also +1. So here our rate of change is +1. Our x value went up by 2, and here it went up by 1. So our change in y divided by our change in x is 1/2. And it is okay to have a fractional rate of change. You would just write it as 1/2. Another way you could write it is 0.5. Both are acceptable. Let me put an equal sign here just that way you know it's not negative. Here's where we get the idea of why we have a vertical change. Our vertical changes are going to be dealing with the change in y, and our horizontal change is our change in x, just like what we did with our tables. If this was causing you problems, perhaps this will help you understand why. We're going to choose 2 points on the graph, and it could be any 2 points. So we'll start at 0, 0. And let's see. Let's choose this one. This right here is 2, 2. Our horizontal change, it's kind of like whenever we're trying to find the distance between 2 points on a graph. You'll notice that we came over 2 units, so our horizontal change was 2. So I'll put that on the bottom. And now we're going to find our vertical change. And that went up 2 units. Well, that means it simplifies down to 1. Our rate of change is 1 for this one also. I'm keeping with the easier ones. The rate of change could be very large, could be very small, could be fractional. I'm just, again, keeping it simple. If it goes up by 1, that means literally you could go over 1 and up 1. Over 1, up 1, over, up, over 1. And you'll notice that it's keeping the rate of change very constant, and that's what allows the straight line to be graphed there. So let's take a look at this one. Just to review, that is our initial value right there at positive 2. That's not an exact point right there. I'm looking for something that's easier to deal with. So let's actually change our line. There we go. And let's go through and show you some possibilities here. So our initial value is at 2. That's not a whole number. That's not a whole number. This one is. So I would have to come over. Let's see, 1, 2, 3. Horizontal changes 3. Vertical changes 2. So what is my rate of change for this? It's 2 over 3. If I go over 3 and up 2, I should hit another nice whole integer point. And yeah, that works. If I go over 3 and up 2, yeah, it's just where my line is slightly off there, and I should adjust that, but it does have the same rate of change. Now, I do want to show you how we will get the same rate of change no matter which 2 points we choose. Let's choose this point and the initial value point. So just like we're trying to find the distance between the 2 points, always tough to write on this tablet. Alright, there's the change in my horizontal, my x-axis. And there it is up to the other point. So 1, 2, 3, 4, 5. Vertical, excuse me, horizontal change was 6. 1, 2, 3, 4. Vertical change is divided by the horizontal change. 4, 6 simplifies down to 2/3. I don't care which 2 points you get. Once you simplify it down on this line, you will always get a rate of change of 2/3. It will always get you the same thing. Why? Because our rate of change, we would say it is constant, as we learned in a previous lesson. And if it's constant, it means it is a linear function or a straight line. If you got questions, come talk to me about it. Please don't hesitate.